Yeah, sorry. This is a bit of a this is
Little no
Steve,
huddle.
little no huddle. Steve was like, "Oh, I must have missed the announcement." I'm like, "Well, not really. It happened like 20 minutes ago, so no, you did not miss the announcement. I mean, not really." So, and Adam, how much of this did you?
I am willfully ignorant. So my wife has been sick all weekend, so I've been off of Hacker News even more than usual. So the fact that your talk at OSFC was apparently the number one story, congratulations, all weekend, totally escaped me.
Well, so yeah, I mean, it was kind of so. I think Dave's here, and he can try. So Dave, so the talk was released actually when I was at another conference. I was at Monktoberfest in Maine.
Right.
I do love those guys.
I really want to get to that conference. I think it's a big regret of mine that I've never prioritized that.
It is so great. And I obviously love Stephen and James and Red Monk, the whole Red Monk crew, and Rachel Stevens, and all of them are just great. So anyway, that was a lot of fun. But I had not had a chance. I saw the video had gone up, but hadn't had a chance to really do anything with it. And then Dave had this terrific tweet thread. Well, he had a terrific tweet actually, which was really, I mean, it's always nice when a fellow technologist really appreciates something that's been done. And I thought, Dave, thank you very much for your tweet. It was great, explaining why this is important. And then someone asked him a follow-up question like, hey, I don't really understand why this is important. And then Dave really took it apart it just like nailed it in this kind of whatever it was, 14 tweets, just explaining why this was important. And Adam, I'm not sure, like, how much of the holistic boot stuff have you been? I mean, the miracle of boot. I'm not sure. I mean, obviously you've had plenty to do.
No, I've been at the opposite end of the universe. So, sort of catching some of the Hawking radiation that gets emitted from that black hole, but and certainly understanding that like we've gone an uncharted path, I think is putting it mildly. But I've definitely not waded into the details.
Yeah, and I think also I feel that you suffered some of that pain. We suffered some of that pain together at Sun for sure. But I feel like, and Josh, I mean, I feel like most of our bias pain actually happened when we were trying to run a cloud ourselves at Joyent. At least for me, I mean, it's like I'd had bias pain in my life, but God, it was so much worse from.
Are you saying BIOS or bias?
Are we going to do this right now? We're gonna do one of these cultural difference moments right now. I mean, don't we? Okay, I probably pronounce those things the same. So when you hear me say unconscious bias, have you been assuming that I've been referring to a basic input and output system?
You know, a lot more stuff.
That's right. It's like, boy, why are we having another conversation about like bias? I was like, yeah, we get no the BIOS.
Like a biopic.
Like a biopic. But
space derailed. All right.
Space derailed, exactly. But I feel like we suffered a lot of that pain when we were trying to run a bunch of machines and really operate them, that I feel we had a lot of that pain.
I think it's probably a tired adage, but like people are like, well, I had this computer and it worked fine. It's like, right, well, get 1,000 of them. And then like 48 of them won't work fine. And it won't be good.
It won't be good. And Josh, you had because Adam here apparently has other things to do other than read Hacker News comments all weekend. But I know I'm among a kindred spirit. You had a great comment deep in the Hacker News. This became a Hacker News story. Dave's tweet got picked up. It got picked up so Adam, just to educate you, it got picked up by Hacker News, and it was somewhat shockingly, it was the number one story on Hacker News for like hours yesterday, long time yesterday. Which is always a mixed blessing, I feel. On the one hand, it's great to get a lot of attention on something. On the other hand, it's not so great to get a lot of attention on things sometimes. And Josh, I think you accurately predicted that, like, well, the informed people have all weighed in, so now it's time for the uninformed to weigh in, and that's exactly what happened.
And just people with different needs, right? Like, again, if you have one computer and its firmware is working well for you, then this is not your problem. Like,
Yeah, and someone said more or less that, like, I've got one computer and this is not my problem. And moreover, I don't see how this could be a problem for anybody. I had a particular example. I mean, I was very time limited in my talk. So I had one example, but he's like, is there any other example where I'm in particular, just to flesh it out a little bit, much to my, and Adam, I'm not sure how much like you had insight into this when we were going through this, but we saw all of these uncorrectable errors inside of Joyent, uncorrectable memory errors. And these machines would just die on uncorrectable errors. And because of the experience that you and I had together at Sun, it's like, okay, so what is our rate of correctable errors? It's like, oh, there are no correctable errors ever.
Yeah, nuts. Yeah, I remember this. This is just
right. And you like, but there's a whole like apparatus, the CMCI, for the operating system to have information about correctable errors. It's like, yeah, those are always zero. It's like, oh, why are those zero? Because it engages in what's called the firmware first model, in which it is the BIOS that actually gets that information and doesn't pass it on to the guest operating system. So I had cited that example, the operating system running on the host. I had cited that example in the talk, and someone's like, "Well, do you have any other examples?" And then Josh, you rattled off a bunch of them. Do you want to talk?
I mean, I'm just reading from my diary at some point, right? It's like,
so do you want to actually go into some of those? Because I do think it's like people don't realize how much is down there and how much can go wrong.
So I would say it's not just the BIOS; it's also all of the management infrastructure in these machines. I think like the problem is not just the BIOS; it's also the BMC and all the other bits that get shoved in there to provide the value add, I guess, that makes it like not just an Intel reference design motherboard or whatever that you've bought. And those are the bits that usually don't work very well.
Yeah.
But like only some of the time. And that probably the biggest problem is that lots of these things work a bit. They just don't work always, and they often fall over the most when something else is falling over and you really needed them
and that's
to tell you what it was.
I mean, that's got to resonate so strongly with people who have not had some of these more pathological problems. Because how many times have you logged into the BMC through its like goofball HTML5 web interface, password admin, login admin, and like tried to reboot it or tried to connect to the console or tried to do anything and have it fail in ways that are
it also doesn't
from
work.
Success. Yes.
Yeah, it just the most irritating example that I have from the last like 6 to 12 is that so there's this red fish thing that's supposed to supplant IPMI. And so like it sounds good in principle. It's like, well, it's REST. It's not very good REST, but it's REST. And like in theory, you can now tell the computer to boot either from the network or from the disk through like a REST thing, which sounds good in principle. That's what I actually want to do in the lab a lot of the time. And it works, I estimate, about 60% of the time. And then the other 40% of the time, either it doesn't seem to update the boot settings in a way that works, but it's really unclear because it sometimes then returns like that its intent is to boot from the network or the disk or whatever I told it, but it doesn't do it. Like it reboot the computer, right. and the BIOS says, I'm getting my instructions, and then it boots from the wrong device. And you're like, well, but what? But then
what happened?
But like, and then if I reboot the computer again, it does it again, and then like, but then sometimes it's enough to like set the boot order a lot of times, and like one of those times that I set it will take, and sometimes it feels like every time that I set it, it actually undoes any progress we made previously in setting it. So it's like not even idempotent. It's madness, and there's no way. So in the end, the computer always boots from the network because I figured out how to like get into the settings menu and do that. And then we control whether it boots from the disk or the network by switching out iPXE files on another computer. It's like, and like, I'm sure that this is a thing that operations groups have internalized as well. That's how computers work. It's like, well, but they don't have to work that way.
Josh, that is such a good point because I think that for so many, and for myself included, at least for a long time, this just felt like the natural order of things. Like, yes, it is frustrating, but it can be no other way for reasons that are inscrutable. And I think that's even true of like people who operate tons of servers outside of the context of like a hyperscaler. There's like sometimes things break and you have to do it again, and it's hard to predict how many times I'll need to reconfigure the boot order settings until it will work.
And it's even worse than that, because this is so sedimented that just as you're describing it, like operators think like, well, this is the way it has to be done. People on other instruction set architectures like, well, if we want to like get people to use this thing, we need to do what x86 does. And you're like, no, please don't. Please, you do not need UEFI. You don't need you don't need Redfish. You don't need all this madness. And watching ARM and RISC-V kind of repeat some of these same mistakes from x86 because they feel they have to, because those are the expectations. It's like, no, please.
I think there's this expectation that by having an ossified standard that everybody purports to comply to, that we won't have to keep redoing all this other stuff. And like,
yeah,
I think people are imagining the world that they would like based on the nouns that they've used in describing that stack. and then sort of, but the problem is that everything they've described is exceptionally complicated. And anytime that you say, well, I can't have control of that piece, then you can't fix it when it's inevitably broken. And also, like, these standards are incredibly wide. Like they have a huge amount of surface area, and a lot of it is often poorly specified. And so, like, it may be that the 3 BMCs that you buy are all standards compliant, even though they all work differently.
Right. Well, and I mean, and Redfish in particular has, and I will, one of my most embarrassing moments, and if Robert Mustaki, if you happen to catch this recording, just, I know I've apologized to you before over this. I want you to apologize again. One of my most embarrassing moments was when we were first hearing about Redfish. For whatever reason, God only knows what had happened to me that day. It just sounded like this is what's going to solve our problems. I'm just like, this Redfish thing sounds great. I just remember Robert being like, I don't think you understand what this thing is and is not. I'm like, but Dell is saying they're going to do it. This is going to allow us to manage an entire fleet of machines. The
problem is the people that built the first thing are now building the second thing. It's going to be broadly similar in quality.
And it's, Adam, have you looked at Redfish?
Not at all.
Okay, I feel that in fact, we should do a Twitter space on like bad web APIs, because I feel like you've seen so many APIs. I would love to know where Redfish ranks.
Awesome. I'm looking this now.
There is a bunch about it that is very, very weird, and it makes it, I think Tom is here. Good. I got to say, good. Thank you, Tom. Tom is requesting to speak just as I'm like, wait a minute, did I see Tom here? Because Tom, I remember you and I talking about Redfish, and you went on a delightful rant about Redfish in OSFC 2019. I'm hoping that Tom still got that rant in him. All right. Well, hopefully Tom is warming up. But
wait, I'm here.
It is not. Oh, good. You're here. Excellent.
Fumbling through the UI. Yeah, no, my rant about Redfish was from experience as well. But basically, Redfish is just a modern syntax. And syntax never solves the problem. The way XML didn't solve the problem, and SNMP didn't solve the problem. And the problem is people don't stick to standards.
That is a really good point, that syntax doesn't solve the problem. That is actually, syntax is maybe part of the problem, but it is by far from the complete problem. And there's also, anytime you've got a field that the vendor can have this kind of like opaque field that's vendor specific, the vendors will just use that for everything.
Right.
I think there's going to be some, right? Because Tom, that's probably one of the other problems with Redfish, that everything is in like these kind of OEM fields.
In which case, like, why bother having a standard at all?
Yeah,
everything can be just YOLO it.
everything is a superset of a subset of the standard, right? Which is no standard at all.
Standards in general are good, but this reminds me of Mothi Roscoe's thing in his OSD 21 keynote, where he says these interfaces have congealed over time, and that's such a great word. And I can't think of a domain where that's more apt than system firmware.
Yeah, it really has. Sorry, I'm eating my burrito.
Yeah, and it's Godwin's law too. There's been so many different organizations doing too much, and each in their little piece.
I think you mean Conway's law, but maybe you do mean Conway's law.
I'm sorry, Conway's law.
It's like, wow, this is about to take a really wild turn. As it turns out, Redfish is from the alt-right. Who knew this? But yeah, no, total Conway's law, where you can see like, oh, I think I can see from the API structure. I think I can see the org chart from here. So, and embarrassingly, I thought and Tom, I guess I myself fell into this trap of like, syntax will solve all problems. Of course, no, of course it won't solve all these problems. It does remind me of when I did a lot of work to go parse the ACPI tables for error injection as part of this problem. And I'm like, okay, we need to be able to inject errors in this thing. We have got no ability to parse these tables today. Write all the software to parse the tables, and then go on the Supermicro machine. I'm like, they're all empty. They're all empty. It's like, oh man, it's like, oh, to be filled in by OEM. You're like, oh man. But then I love the Josh. You see that Hacker News thread that someone just in terms of like we were talking about the expectations of sedimentation. And there was a line of like, removing layers of abstraction seems like it could lead to incompatibility. I'd much rather have proprietary blobs everywhere than incompatibility. It's like, well, how about proprietary blobs and incompatibility? Like, why choose? You can actually have both of these things. So when we set out, and Josh, I don't know if you want to elaborate on any of your other diary entries. You had it was a good list, I feel. But it was
I felt that it was a bad list.
Fair enough. The opposite of a good list. Yeah, it's a lot of pain. But so when we set out, you said yourself that like this is like a chunk of these are the BMC, so we want to get rid of that within SP.
Yeah.
We wanted to get out from underneath this Redfish problem, which is part of the problem, Adam, is that the BMC is just like hanging out a web service on not the internet, hopefully, but often,
but in some cases, yeah.
But in some cases, yes. And it's like, you really don't want your BMC having a web services stack. That's not a good idea. Like, you really want that thing to be much more finely controlled. That is a recipe for vulnerabilities. That's a lot of surface area.
Yeah, like when you start scratching your head and thinking, like, what is this thing I'm typing admin into?
Right.
Like, there's actually probably a bunch of software running that.
There's a bunch of software. And the problem, actually, there's an interesting kind of threshold where, and I didn't really click for me until I saw, at OSFC, really good talk on the structure of HP's BMC, and like what the actual ASIC looks like. And one of the problems that they actually have is that once you exceed the SRAM in a microcontroller, then you are actually forced to get DRAM for this thing, for your BMC. So this is not even the computer, right? This is the computer to manage the thing. And once you have a big enough footprint, you need DRAM. And it's like, well, what am I? And so one of their problems is they can't find DDR3. Like, they just like not for sale anymore. So they are having to put DDR4. It's like, oh my God. And
so like, how big of a computer do I need to manage this computer?
Right. It's like, so it's like, I have to buy like an F1 car. Like, I just want to go grocery shopping. It's like, yeah, sorry.
Well, pretty soon you'll need a small processor to help you boot your BMC.
Sort of meta BMC.
Oh my
right?
God, that's coming. Exactly. Because this BMC is not going to boot itself. Like, it actually needs. But seriously, Tom, when you talk about like, because like that thing now, especially DDR4, one of the things we really appreciate, I appreciate much more viscerally than I have previously in my life, is how long it takes to train those DIMMs.
Right.
And so now, like, your BMC actually can't boot that fast because it needs to train its DRAM by the way, that it doesn't even need. It doesn't even want. It wants to actually have like, so you. And a big part of that problem is like, well, your footprint got too big in this thing. Like you wanted a web services stack, so that needed Linux, and now you have, tens of megabytes, hundreds of megabytes of footprint, and now it's DDR, and it's like multiple organ failure. So we knew we were going to get rid of the BFC. We have an SP. We only use the SRAM. We don't have any DRAM on that thing. We don't have any DDR on that thing. So that simplifies a lot. But then the other big piece that we knew we wanted to do, which is I was talking about in this talk, is the actual elimination of that proprietary BIOS that executes before the bootloader. And that code is often unseen. And I think a big part of a challenge that we have in the industry that I'm not sure how clearly I called attention to it, but there is an unfortunate codependency between the microprocessor vendors and the BIOS writers, the IBVs. And they end up kind of developing this stuff together in a very undocumented or unseen fashion. And it means that like no one else can actually do the platform enablement because it's not documented. And I don't think this is pernicious necessarily, but that is a big part of the problem here, is that the parts themselves are not documented.
It seems like not just not documented and not just potentially pernicious, but also fragile in a way where once they get it working, it's sort of good enough. Very hard to understand the failure modes, and probably hard for them to document. I mean, obviously we've seen hard for them to document because they don't necessarily understand how it works.
Well, they definitely, at the very least, it is in terms of that lowest level of enablement. The sequencing is not completely elucidated, and it is clear from their own implementations that what we found a lot is units that would be initialized multiple times, which clearly you shouldn't need to do. It's kind of in the name. Clearly, you should only have to initialize it once. So I think there is some of that, of like they don't know exactly what's required and what's not. And then once it's working, you don't want to actually dork with any of it, which is the other big challenge. Dave, go ahead. You're here.
Hey, I just wanted to add to that. The other big deal is lack of diagnostic information. So to your point about stories of weird firmware problems, one that I had on a single machine, not even at scale, was the management engine was just broken on an Intel board, and it just brought up a single core locked at 800 megahertz, and the rest of the firmware just didn't do anything about it. It actually, maddeningly, it constructed. I don't know if it's ACPI or anything else, but it constructed in all of the state it handed to the operating system. It's like, you are the owner of one 800 megahertz Xeon core.
So
have a nice day.
All the way up to say, here, this is what I have for you.
Yeah. So this is like a machine I bought and assembled and booted. And it's like, wow, this is booting really, really slowly. It's like a 3 gigahertz part with
it's
multiple
like your Pentium.
cores. Yeah. And eventually found, I went and dug through the terrible BIOS APIs, not APIs, UI, and eventually found, hidden in a sub menu, the management engine is in recovery mode. Well, that sure sounds bad. And eventually, once I had that, found, went online and found that the board vendor had a forum post somewhere that said, oh yeah, that happens sometimes. Put the management engine back into manufacturing mode, reflash all the firmware, and it should be fine. And it's like,
that's confidence
really?
Inspiring. Yeah.
This is your response to your firmware getting it kind of wrong here. Like, couldn't you have told me that something was amiss?
Just turn it off and turn it back on. I mean, that's what the entire industry does when something doesn't work right.
Yeah, I mean, if you find a dead mouse in your soup, that happens from time to time, and remove the mouse and continue eating the soup. It's like, I don't think
exactly.
I've got a lot of questions about how the soup is made now.
Yeah, and just count my lucky stars. I had one server to recover, not 10,000 in a data center. That would have sucked.
Yeah. Wow.
And another one where I can't share too much of the detail, but due to an assembly error, the CPU came up with like half of one of its buses missing, and so you just had a terrible performance degradation because the firmware somehow managed to muddle through like, oh, like 50% of my hardware is not functioning. I'll just initialize the rest of it and function at half speed.
Okay,
and not
so
tell anyone about it.
Yeah. So, all right, this is a really interesting point, and these are, I mean, very painful experiences. But I think that because part of the challenge you have in both these cases is this lowest layer of firmware knows that things are very, very amiss, and
Right.
it has no real way. It's like I wasn't handed a flare gun. Like it has no real way. It's like, I don't know, just boot it. I don't know. I mean, it has no way of indicating it knows there's a raging inferno down there, but it has got no way of indicating it. So it is up to, a higher level software has got no way of kind of querying that kind of state. And I do feel like this is a really persistent theme that we see, where the element in the system that knows that something is amiss has no way of communicating that to the element of the system that can actually do something about it.
Well, this is part of the consumer electronics heritage, where you go to great lengths to make sure you don't get a support call.
Well, yeah, that's interesting, Tom, because I do feel that like part of the problem here is that we have, because we've divided the world into those that generate the systems and those that generate the software. It's like and in part to like deprive those that generate the hardware from any kind of margin. It's like, well, yeah, I don't have enough like staff to invest. It's like, yeah, I don't know. It goes into recovery mode sometimes. I don't know what to tell you. If I had more than 3% margin, maybe I'd figure it out. But which is another part of the challenge here. Steve, you had your hand up.
Yeah. So first of all, I'm excited we're finally talking about this stuff, because I think this whole thing is like one of the coolest things that we're doing, because it's like an area. Before I worked at Oxide, I didn't know any of this stuff existed, really, to be honest. And like finding out all this garbage that's in there and the fact that we're getting around it is something I'm like extremely excited about, and it's very cool. But also it's kind of that like slightly outside perspective. There's this quote by Adele Goldberg I've liked for a really long time, which is, in Smalltalk, or like in an object-oriented code base, everything happens somewhere else. And like that's the way that I feel about this layers of firmware, is that like we've built all these like layers of like people writing these different firmwares that you only care that your thing works well enough to put the blame on some other vendor somewhere else in the stack. And that's like why we end up in these kinds of places where it's like, oh yeah, that's a bug that happens, but just like, it doesn't matter. Just like reset it, like it'll be fine or whatever, because you just don't have control necessarily over what some other crap somewhere else in some other layer of this is like doing. And so I don't know. For me, like in that Hacker News thread, someone's like, what's the business case for doing stuff like this? And it's like responsibility. Like our job is to make sure the computer works. How are we supposed to make sure the computer works if there's like all this other garbage that's literally lying to you, that's like written by other people, and then you can't inspect or read or know what's going on? And so that's
and
like, I think it's important.
Yeah, totally important, Steve. And then you also don't even know who to call. So if you somehow manage to like get to the right person, one of the things that Dave, I'd be curious to know how often you heard this. We definitely heard this a lot, which is, no one else is telling us about this. Like, we have shipped millions of these, and if it were as broken as you say, we'd be hearing it from everybody. Like, you're the only customer we've heard this from. And you kind of believe that for the first 1,000 times you hear it. And then you begin to realize, like, wait a minute, no. Everybody else is seeing this. They just don't know who to call. They don't know how to express it. They don't actually realize that this is a problem. And so
we get learned helplessness too. Like, I was talking to a friend who works at a big company on their like platform team, and he's like, oh yeah, like if I report this bug upstream, they're going to go, sure, that's a bug in some firmware. We'll file an upstream bug. And like, who knows if that ever even gets looked at, let alone taken care of. So why would I file more of these bugs? Because like, they're clearly just getting ignored.
Totally. And I think I got so frustrated with one of these that years ago. So in particular, do you remember the perk, the parity errors we were seeing on our perks, Josh? Back in the day, we were seeing these parity errors, and Dell. This is on boot. The perk, which is an HBA, would report a parity error, and then it would just stop. Like I'm not gonna. I'm just like I'm done. I'm here. I'm stopping the system because of this parity error, which I don't know. Maybe I'm not sure.
Wait, like so it did like a read from a block, and that was it. Parity error. Good night.
It would say parity error, and then it would stop booting, and you would need to reset the system. And then if you reset the system, it would frequently work. And the Dell in particular, so we were running our Illumos derivative, SmartOS, and they're like, this is a SmartOS bug. And we're like,
SmartOS is not running.
huh, that sounds very strangely like exactly what I told them. I'm like, okay, if this is a SmartOS bug, if SmartOS is able to travel back in time and space, and somehow distort your software that runs early in boot, like that's another problem. But it's like, no, it has to be because we're not seeing it anywhere else. No other customer is seeing this.
What about the machine that we've never installed the operating system on? What about that one?
Right.
Yeah, but do you intend to install SmartOS?
That's right.
Ah, there it is.
That is exactly. And I was so frustrated by this that I was at a conference, and this is, back in the day when there was a little more physical infrastructure, and I was kind of calling them out on this, and I'm like, hey, just show of hands, has anyone else seen on this Dell Perk card? And you could see like a room of like maybe 300 people, and there were like 10 hands that went up, which is a lot. And everyone is like looking at one another being like, oh my God, there is someone else. Like every one of those had been told you were the only one seeing this. And of course we weren't the only one seeing this. We were, so I think, Steve, just to your point about like the value of this being, and I did feel like some of those Hacker News comments were ridiculous. Like, I don't understand the business case for this. It's like, it's a firmware conference. It's not that's all right. This is not the open source business case conference. Anyway, but I thought you made a very good point about like, no, like the point of this is you've got one system. And so you've got one entity that's going to bear responsibility for the whole thing end to end. If anything is broken,
Brian, it's the curse of vertical integration, because if we had two companies, then we could stand there like the Spider-Man meme and point at each other like Dell does
right?
with Microsoft and go on and on in the industry. But the fact that it's vertically integrated, unfortunately, we've got one throat to choke.
Well, okay, so I actually do wonder about this. Like, if we see a higher proportion of this, because like the fastest way to like to get something blamed is just to be doing something that other people aren't doing. Like, oh, are you running OCaml in your stack? It's OCaml. Like, are you like, what? Like, are you running? Oh, is it this operating system? Oh, this is what's causing the problem. Like, I just need to. Can I go into your environment long enough to find something that is just like not Windows, and then I can blame that. And then all the vendors. It's like I just need to find another vendor in here. Can you please give me your vendor list, and then I know who to blame. Which is very frustrating.
Yeah, but I don't know. I feel like both. That's like the story of the industry. Like, remember there was this era when like database vendors wouldn't support you when you were on a virtual machine because it was different, right? Because they could.
Because they could.
Yeah.
Right. Right. Exactly. There's nothing about a virtual machine that makes it right. It's just so. And it's like you really need to have a culture of like, you got to own the whole problem. Like, I don't care. If it's because you're on a virtual machine, maybe, but like we need to own the whole problem. Sorry, Josh, go ahead.
I was just going to say, what about Richmond 16? I'd forgotten about it until Patrick mentioned it a few minutes ago.
Yeah, so you should. So Richmond 16. This is one. Adam, how many bug numbers do you know? Do you know, like, you know what I mean?
I know zero bug numbers.
Is that true?
Like, absolutely. When you are dropping in like these iconic bug numbers from history, I just nod along. I'm finally telling you.
I don't know if you have lived a charmed life or just a healthier one. I mean, if you
just an enumerate one, I don't know.
Yeah, right. It's just like. No, I followed, like I worked through it in talk therapy, and now I can't remember the bug ID anymore. It's like, wow, that's great. No, Richmond 16 is a bug. Josh, do you want to describe the symptoms of Richmond 16? Because this really was like, this was a wake up call for me.
I mean, the worst part about it was the RAM disk that we booted our operating system from would be corrupted, just a few megabytes of it in different places. Sometime after control was handed to the operating system, like a minute after boot had really sort of was well and truly over. Like, then you would go and run like LS, and I guess depending on how your image had been constructed, your LS would not work
because a part of your RAM disk had been clobbered.
Yeah,
like a part of your RAM had been clobbered,
and we never really nailed it down again because the BIOS was like closed. But like when we turned off the UEFI network stack, not that we were using it, but when we switched that option off, I think it got better. But certainly we like just refused to ever use those physical pages ever again.
Okay.
Like
sounds scientific. I mean, not that you can be more scientific than that, but
well, no, but it was
well. So we were checking for like SMM activations, and we had like Keith had spent a lot of time on this with like we had nailed it down to specific physical memory ranges, like a couple of specific physical megabytes. I think were subsequently being overwritten with just trash, and like there was no SMM activations that we could see, assuming the CPU was being honest about that, and there were no watch points that would fire, so it's not like it was our fault. So like it must have been DMA from outside the CPU, and so like we suspect that the network card had been configured in such a way that it was eventually like pooping some packets into this space or something, and like it was doing that for some amount of transfers after boot had been handed off, and because like the firmware is gone at this point, it's not running anymore. So
well, it's not running in air quotes
in any way that we don't want it to be running. Not running in any way we can tell.
But this is like one of these moments, and I totally forgot about Richmond 16 as well until you mentioned it. But this is one of these moments that was very revealing in terms of like, oh my god, there is software that is running. Like there shouldn't be anything else running on the system. We are the operating system. We control the CPU. No one else has access to the operating system's memory. It's like, well, it's mostly true. Not always true.
So I know we have hands up, but I really want to dovetail to the SMM there if we could. I mean, just because I feel like this was such a revelation for me coming to Oxide. And I think folks on the space might not have heard it or reveled in its majesty.
Yeah, so SMM is the system management mode, and this is a mode that the CPU can enter whenever it wants. It can be there as long as it wants. It can do whatever it wants, and there's no way for the operating system to know that it happened.
But it's not like a virus. This is not malware, ostensibly.
I think that's really going to pivot on your definition of malware. It's like it definitely gets going to get blurry, but no, it's not malware. And it's just like, oh God, okay, like why would you do that? It's like, well, there are various reasons that you can enter SMM, and there are various reasons why it may choose to enter SMM, why SMM can be entered effectively asynchronously. And the thing that is really alarming, you got no visibility to what that software is. The thing that I did not realize until, years after we knew SMM was a thing, and certainly putting pressure on Intel that they were ignoring to give us some visibility into when we were in SMM, and a suspicion that there was a lot of software in SMM, but you actually don't know what's there. What I did not realize, and I knew that it was originally done for like laptop suspend and resume, which is the way that was working without any OS support, is because SMM was actually doing it. It was like, okay, like I can kind of understand that.
Back to Dan's point about this system being congealed, right? Because you're breathing in this magic functionality that your hardware can just do, independent of any proper OS support.
That's right. And they got a little too strung out on that. And in particular, the one that I heard that was when Ron Minnick was describing, I don't know, maybe this was, I can't remember, I heard him say this in 2017 or 2018, that there were mouse drivers in SMM. You're just like, what? Because when they were initially implementing USB mice, they wanted it to work with a PS2 mouse driver. So there was a mouse driver sitting in SMM. You're just like, whoa, that's no. That is not 100% not a good idea. And so it's troubling. I mean, it's the kind of thing that's like, when people would talk about what's in SMM, a part of me would be like, that sounds kind of conspiratorial. And then you realize what is in SMM. You're like, as it turns out, that was not conspiratorial enough. It turns out it actually, it is very, very troubling, the amount of software that's in there. So we leave SMM empty. So there is nothing in SMM Unfortunately, you cannot completely disable it. You have to deal with it one way or the other. But I know Matt and Ian have got their hands up. Matt, do you want to chime in?
Yeah, sure. So on the parity error anecdote from earlier, am I correct in guessing that another thing that made that problem annoying, to say the least, is that the error was only displayed on the VGA console?
Yes, you guessed correctly. We have a lucky winner. Yes.
So you would have to go in there with your with the VNC equivalent client that was built into your BMC web interface and look at and then see the error that way, I guess.
That's right. And I believe, and Josh, maybe you remember, someone else remembers exactly, I believe you could press F1 to continue. So this is one of these where it's like, yeah, I'm just going to hang out until you press F1. It's like, okay, there's
it's a PC. There's someone sitting in front of it.
That's right.
Another thing, I don't know if this is SMM or just the BIOS hanging around and butting in where maybe it shouldn't. But I remember in like '94 when I was a teenager, on Packard Bell computers,
nice.
when on Packard Bell PCs when running DOS or Windows 3.1. Yeah, while the OS, such as it was running, you could hit Alt S to go into the Packard Bell BIOS setup.
Oh my God! Well, okay, yes. So that would be interesting to know whether that was SMM, which definitely could have been. I mean, SMM has surprisingly old origins. It's from the 386. So it could have been SMM, actually.
Or it could have just been, I mean, the BIOS was handling keyboard interrupts anyway.
Right. Yes.
And this was a school computer, so I didn't have like any games installed on it that I could use to like probe the limits of this function.
But a school computer, that's
where it could and couldn't run.
God, if you were like my kids now, whenever I have a new piece of electronics arrive at the house, I have to be the one to unbox it because otherwise they will find the parent controls and they will lock me out of my own device. Do you have this happen, Adam?
No, I think I've already taken control of like the Wi-Fi router, which is like you got to lock that down, parents, because like that's the point of control of the whole house. If you can turn off everyone's internet, like you can make your teenager show up anywhere.
Right, exactly. You can make it well, but similarly, I'm surprised that you're self-constrained of like not actually be like, hey, I can actually set some passwords on this, but I can actually ransom this BIOS back to the school.
Well, I kind of did the opposite thing that the year before when I was at another school where they had Mac computers, and I discovered that I could turn off the quote unquote security software that was installed on those computers by holding down Shift while the OS was booting to disable system extensions. But I was a good kid. I reported it to my teacher.
There you go. Reported that got a CVE for it. That's pretty funny. And I remember I got Packard Bell. So I remember being a kid being like, wow, Packard Bell, that's a funny name for a Hewlett Packard machine. There must have been litigation between Hewlett Packard and Packard Bell, right? There had to have been. I don't know. Well, it's like one of those questions I've always wondered. Ian, you had your hand up.
Yeah, one aspect of this work is kind of about Oxide's kind of balance sheet, right? It's about having happier customers, about reducing your support contact rate, about having fewer like head scratching support cases. But I am kind of curious about how you take this thing that is kind of invisible and make it more visible and more transparent to customers so they understand this aspect of the selling point of why you would buy an Oxide rack as opposed to like a Dell machine. Like I'm curious about whether you've thought about, what is the Backblaze hard drive stats, but for support contact rate for my machines doing weird shit.
Yeah, no, that's a great question. And I think that, just to be clear, I don't know that we view this as a selling point per se. I think to Steve's earlier point, this is enabling us to deliver a high quality experience, and it's the high quality experience that is the selling point. So I think that this is a necessary implementation detail of that.
But the negative consequences is something that most of the customers I think we've spoken with, correct me if I'm wrong, Brian, but it resonates with them. When you're like, have you ever been in a situation where you've got two vendors both gaslighting you, both telling you you're the only ones who it's ever happened to, never get a satisfactory answer, they tell you to reset it, it happens to 10% of your fleet. Does that ring a bell? Like, we see lots of nods in those situations.
You see lots of nods.
And of course, we can't say, hey, that will never happen to us because, we're smarter than those folks. But we can say, like, it's, we have taken these steps so that there are not these areas of mystery and uncertainty and lack of visibility.
That's right. And I think that the thing and I knew we would be able to deliver that kind of responsibility. I have to say, and then Josh, be interested to get your take on this. I also thought we would be taking enormous technical risk, clearly, because no one's really done this with an x86 machine before. And I also just assumed that it's like we are taking a slower path by doing this, that this is going to be a harder, slower path. And one thing that is kind of amazing to your question about the value, Ian, I would say unequivocally, we actually took a faster path. Which I never would have thought that this was actually we were able to, and I mean, in part because this is the enormous skill and expertise and background and resolve and grit and so on of the people involved. Robert Mustaki, Keith Wazowski, the folks that were really like driving this were very determined. But I also, having seen the way this platform enablement, the way it's done, even for hyperscalers, it is not fast to rely on a proprietary BIOS vendor to support a new platform.
I think we had a much longer ramp up to the point where we're going to be able to sell something than if we had just put Super Microsystems in a rack. But we will attain a much higher top speed once we get up to speed, I think. Because, I mean, recall, like, the decade, or in my case, 6 years that we spent at Joyent, like, how many engineer months did we, like, pay in terms of my salary for me to, like, just, like, fiddle with BIOS settings? I mean, like...
I know. Well, true, but Josh, I also think that, like, once we made the decision to chuck a BMC and to have a service processor, like, we were already... Once you're on your own board design, you are effectively already on your own. From that moment, it was actually faster for us to build a holistic system than it was for us to engage with an IBV to go build their variant of a GISA for us.
Yeah, I think that's true. We also just didn't need as much stuff. Like, it's not like we had to go and re-implement all of OpenBNC and all of EDK2 and all of these other things. Like, because we actually just want to jump into the OS as quickly as possible, and we don't need to be compatible with anything else, at least right now. And like,
we don't need to be compatible with anything else at this layer. One of the things I do love about Oxide is that we are often simultaneously ripping out a legacy abstraction at the bottom of the stack and then re-implementing it virtually. So we've got where we are. I know that it's been fun to watch folks go deep into old abstractions and then re-implement them in Propolis or machine model. Sorry, Steve, go ahead.
It's difficult to incorporate debugging time or like after when something is working into like time estimates. We see this with Rust in general, where people are like, stuff takes a lot longer in Rust. And it's like, well, it initially takes longer, but then you spend less time after the fact debugging weird issues. And like, sure, if you're using, say, like Ruby, you may get it like quote unquote done faster, but then you spend all this time later figuring out where bugs happen. And so I'm not saying these trade-offs always make sense that way, but I think it's kind of a similar thing where we chose this path that we maybe thought would be slower, but it turns out it's faster in the end, just because like how we perceive of what is fast and slow is sometimes not like actually accurate. Those months of time you spent adjusting BIOS systems, Josh, weren't like considered in the like how long did it take to get this solution implemented, because that's just like the way that we think about these kind of processes. Or at least I found that to be true with software development in general.
No, I think you are totally right, and you are especially right in this domain, where everyone's responsibility is just to get their own little thin layer working and hand it off to the next thing. And then when the whole thing goes sideways, it's like don't worry, you're going to get away with it. No one's going to come back and blame you because it's such an opaque layer.
Just tell them we've never seen it before.
it's faster to get working is like for a certain definition of working, which often doesn't actually mean working. It means like working enough to get sent to whoever wants to accept it.
That's right. That's right. And so no, I think you're exactly right. And I think that and you're right that the kind of the way we think of like, when is the system done? And for us, like the time for that has been, I think it's been, I mean, for what we've been able to do, we've been able to do it in a remarkably short time. And then I think that another question that's been asked is like, well, what's going to happen for like a next generation of the CPU? And it's like, yeah, next generation of the CPU definitely is going to require work, but they're incentivized to keep a lot of these excellent abstractions, and provided we get good documentation, we're confident we can actually do it relatively quickly. So, Ian, is this helping to answer your question?
Yeah, I think the piece that I'm kind of missing here is how you kind of beat that drum in a way that doesn't require customers to talk to other customers. Like, is it I'm going to post blog posts about not just here's this extremely weird issue that took us weeks to debug, but maybe I do a blog post which is like, here's a support case that probably would have taken 4 weeks, but instead took 4 days because we had X, Y, and Z built into the kind of core brainstem of this rack. Like, you know, I'm just thinking through like how you sell this benefit in a scalable fashion instead of through a, you know, one-to-one sales conversation, or selling purely to people who are currently, you know, at the throats of their current vendors.
Yeah, and I think that, I mean, it does become an implementation detail at some level, and it becomes, ideally, it becomes one of these things that just allows us to build a better thing. And what is the demonstration that it is a better thing, that is a higher quality thing, and you can get quantitative about it, but you can also just get very qualitative about it. Like, I mean, I think that, and Apple has done this for years, where it's like, no, like this thing is just, it works. And I am curious about the implementation details of why it works, but from an end user's perspective, what I appreciate is that it just works. Todd, you had your hand up.
Yeah, so I guess I don't know nearly enough about this, so this may be a dumb question, but I'm a little curious. How much does your design constrain you in terms of different types of hardware that you want to put on the machine? So if you wanted a node with different GPUs, different CPU, or maybe a machine with a different network or like a larger network, what would you have to change about this setup or anything?
Yeah, great question. And the answer is I mean, like the Magic 8 Ball, it depends. So, I mean, if you definitely are, but I would argue one is anyway, it is a big lift to go to, for example, Intel x86 versus AMD. That's a big lift. But that's a big lift anyway. And with Intel, we've got the management engine that would be something we'd have to contend with. There are a lot of reasons why we chose AMD over Intel for the CPU. But so that would be a big lift. Changing for this particular aspect of having the kind of the holistic system design and having the operating system do the lowest level platform enablement, it really is the host CPU that is the thing that is affected the most. Changing the NIC, for example, or a GPU PCIe device generally won't be that affected. I should put all that with caveats, but what this really is about a tighter integration with the host CPU, and it is a tight integration with the host CPU. But I would argue that like you've got a tight integration with the host CPU anyway. So this is more just allowing one to deliver a better thing with it.
But is this accurate to say we'd have to do kind of a similar scale of work if we didn't go with this model, if we didn't go with this holistic boot approach, but a lot of it would be out of our hands and in the hands of other vendors where we don't have transparency or visibility into the operation of these things.
Absolutely. And we also, again, because we have chucked the BMC, we also have our own board design. So, I mean, we're not just like chucking an Intel CPU in there. We would have to do a de novo board design around Intel x86, and it would be a lot of work. But that's part of the reason, when we conceived of Oxide, one of the things that we wanted to go do, and I think we heard Kate talk about this a couple of weeks ago on the supply chain, is like we very deliberately wanted to have deep partnerships with folks. We're less interested in the ability to kind of plug random stuff in here. We really want to make very conscious decisions. Todd, does that answer the question?
Yeah, I think so. I think so. I'm mostly curious, like, you know, if this thing could scale to like a 240 rack HPC machine or something like that, because I don't know, because of where I work. So I'm wonder if that's on your radar, because that could simplify our boot process a lot. I don't know if you know how long it takes to boot these things, but it's a pain in the ass.
No, yeah, yeah, but I would love to hear stories, boot time stories. Yeah, so we need. Tell me a bit about, to the degree you can, what are these mainly GPU based systems, or what do they look like?
These days they are. So like since our last system, which I guess we put on the floor in 2018, which is Sierra, it's a 17,000 GPU system. It's like 4,000 nodes, Power 9 plus Volta. You know, in the early days of bring up of these systems, like it takes the vendor forever to get them booting quickly, like to the point where we actually have boot speed requirements in the SOW. And I mean, it's still hours, right? Like if you have to restart the whole machine, some nodes aren't going to come up. And you're going to spend a long time getting that thing working. Like when we had to do the government shutdown, I don't know if you remember that, but we were required to turn off all the machines, which is just a giant waste because like they're not going to come up immediately and start running things when the government shutdown ends.
Right.
So, you know, having a faster machine for something like that, or a faster boot time for something like that would be good. Not that government shutdowns happen all the time, but just in general, like for managing, you know, thousands of nodes, this sounds super good. I'm just, you know, curious. And I guess the other facet of the question is, when we buy these things, I mean, we buy them like 5 years out, and there's a lot of collaboration with the vendor on like non-recurring engineering. So that's like innovative stuff that they do to make sure the machine's deliverable.
Yeah.
And you know, so that's kind of cool because the vendor gets to.
Is that me?
They can do crazy things in that. They can do cool research to make the machine work in 5 years. But you know, a lot of it is, you know, what's on the vendor's roadmaps for things like GPUs, because that's where most of our power comes from these days. And if you can't, you know, pick the best GPU for the job, then it's going to be hard to compete on one of these procurements, right? Like if you're tied to specific hardware. So that's kind of where the question is coming from.
Totally. And that's what we tried to, I mean, we felt like in picking AMD Milan, we were picking the best CPU. We don't have a GPU offering at all, just to be clear. So we are only got CPU networking storage only. And GPU is definitely something we're looking at. Accelerated compute is something we're looking at very, very closely. I will tell you just bluntly, part of the reason that we are not, we haven't figured out what we're doing for accelerated compute yet is because we don't feel we can deliver oxide value with NVIDIA. And we don't feel we can do that in part because NVIDIA doesn't really have an interest in partnering, from our experience, in partnering to develop a truly integrated system. I don't know, Todd, it'd be great to, maybe that's wrong.
Well, funny you should mention that because, like, I don't know if you saw that Oak Ridge's machine, which is part of the same procurement as ours, is a giant AMD system, and so is ours. So NVIDIA didn't win any of the exascale procurements for reasons, and you know that's part of the competition thing, right? A lot of people were like, "Oh, you can't get that other GPU stack to work." Well, we're interested in it because it's competition. And,
yes.
Right. And so we're trying to create a market for other GPUs because of reasons. Like you mentioned.
Amen. And I also feel that like part of the reason it's really important to do that, and I mean, that's great that you're doing that. Part of the reason that we really want to see, whether it's a reforming NVIDIA or a different player like AMD, but we really believe in open source software. It doesn't feel like a deep thought, but it's really important that when you've got someone putting in all this time and effort for your platform enablement, you want that to be something that doesn't have to be repeated, and making it open source is the way we have learned. That's the way that happens. I mean, if it weren't for open source software, I mean, it's just, And Adam, I don't know if you have kind of these same moments where you think like, oh my God, open source software is such, yes, it's a big deal, but it's an even bigger deal than that. I mean, where you look at all the stuff that we build right now that rely, even at Oxide, where we're pulling in all of these open source components, it's unfathomable to think of.
It is staggering. It's staggering to think of like doing this from nothing, like the way that we did in the bad old days, to do it literally every code of being one that we had written.
And I think you see, and Steve, kind of your earlier point of like sometimes it takes years to see these effects. I feel like I mean, this is true for a lot of programming languages, but Rust is like a culmination of many different open source bodies of work. And it's building on so many different layers of open source, some that are directly in the project, like LLVM, and others that were able to really directly inspire it or were able to pull in other components. So Todd, our big belief is that like that platform enablement really has to be open source. And we can't do that realistically with NVIDIA. And that's a big challenge. I'd be great. I would love NVIDIA to realize that it is in their interest to allow people to more readily build products around them, but that's not where they are right now.
So you made, just on that point, I mean, we have a whole paper at SC20 about vendor stacks versus open source stacks for HPC machines. Because there's like sort of a historical perception that the vendors add a lot of value with their proprietary stacks, and so we pitted like an OpenMPI plus vanilla Linux configuration versus like what the vendor of our machine was providing, and the difference isn't that big. I mean, and also like on the MPI side, it's a toss up what kind of network performance you get. So it's like, is it worth making all this stuff work with custom vendor compilers and custom vendor implementations of everything and proprietary things? So, I mean, basically we're thinking no. But on the other hand, like we, at the moment, kind of because of the procurement we did where we tried to, build a new market for different GPUs, there's only one integrator left in the HPC world who builds systems at our scale. So we're trying to figure out who could be new integrators there. And part of that is through open source. We think we can take on a lot of the responsibility for the stack, work with the vendors closely, and work with them to use more of our stuff, like our resource manager, our stuff, vanilla like Linux for the operating system, and introduce more competition there. But it's not clear who will step up to that. So it's a wide open space right now.
Yeah, that's really interesting. Well, for our part, we're obviously open sourcing everything that we're doing at Oxide, and it would be great if someone else is like, hey, you know what? If I make a system look like that, I could actually run their service processor. Or I could run Hubris, or I feel like we would like to inspire other folks, and this is part of the reason it's all open, is because we've benefited from that, and we want the industry to be able to benefit from that, especially in domains that it's like where you should be able to benefit from all these things. So hopefully we can collectively put some pressure on folks, because I just totally agree with you that the open source has got to be the path for this stuff. And Drew, I saw you getting in here a while ago. I'm not sure if you had a question or a thought, or maybe not. And then let's see. I know, Ian, we got to your question slash. Or did Ian drop off? Ian dropped off. So in terms of where we're going, it was exciting to be able to demo the booting. Josh, thank you very much, by the way, for arranging for the lab machine so I could actually demo it on stage. That was a lot of fun. But it is always nice when you demo booting and people actually appreciate it. This is not. It takes very rarefied air to appreciate a boot demo. But it was actually really exciting to be able to. And Josh, is that a Star Trek reference? Like, the station now under computer control? Is that a?
Yeah, it's from The Search for Spock, Star Trek 3, I think, where they nick the spaceship. They make off with the spaceship, and of course they don't make off with the crew. So like there's this like throwaway line where like the chief engineer is like, don't worry, I've just rigged everything up to be automatic. And it's like, why don't you do that for every spaceship? And secondly, and also why is there a crew of more than 4 people for any spaceship then? Regardless, it on every screen in the background, to make the set look good, is this little like Commodore 64 like Federation of Planets picture with this station is under computer control, where there would normally be like something blinking for an actor to sit in front of. Anyway, it doesn't. It's just, it looks like it does in the message of the day there. But
is this a common reference, or is this just a moment that really spoke to you?
I think I may be the only person that remembers this. I'm sure I have looked for a screenshot of it. Haven't found one that I didn't make. So like it just anyway,
this turned from a thank you into a public humiliation very quickly. I
don't feel embarrassed at all.
Thank you, Josh.
People should live their best lives.
Look, I saw Search for Spock in the theater, and I don't remember any of this. I mean I was
well, fair enough.
I mean, Search for Spock. I don't know that it was. I'm glad that it was. Because when I saw it, I'm like, this has got to be a reference to something. And I Googled it. It does Google somewhat well. So I don't think you're the only one.
Really? So you were able to find a reference to the film? Fair enough. There must be some OCR that's gone into like alt text generation or something. Screenshots of things.
All right. Well, this is going to be good because Adam now knows what the image for this. He's going to have to. We're going to have to go get the Search for Spock on. Is it even on streaming?
There it is. Yeah, make my job easier making the video tomorrow.
Exactly.
I got to listen to an audio described version of that movie and see if and pay attention to whether the audio description narrator picks up on that on-screen message.
Yeah, exactly. Go report back. All right. Well, that's. But it was fun to demonstrate that, Josh. So thanks again for. And actually, Josh, it's also worth maybe. Do you want to describe a little bit about how we have phased boot? Because I think this is actually pretty neat.
So we have small. So the operating system eventually boots from just a RAM disk that's just like it's a ZFS file system that we stick into DRAM and then mount as a file system. And but in order to get to that RAM disk image, which is pretty big, it needs to live on some PCI devices. And because one of the things that we're not doing is initializing and uninitializing stuff, we are not going to get to the PCI thing until much later. We need the drivers that are on there to get to the PCI stuff. So there's some chicken and egg problem stuff. So we have a very small collection of kernel modules and files that live in the NAND, like the NOR flash, the SPI ROM, where the BIOS would traditionally live, I guess, on a computer. And we are basically just putting a very small subset of files that we need to get started in that ROM, and the computer pretty much jumps straight to that through some small bootloadery stuff that Dan wrote. It's pretty much straight to the kernel, and then there's enough drivers and file system stuff in that thing that's a little bit like an init RD, I guess, like an initial RAM disk image thing. It's able to load those drivers and then mount copy in the RAM disk image from one of the big storage devices once we can get to it, and then boot really proceeds pretty much normally the way that it would on any other system, any other like Unix system, pretty much. And it starts up and a bunch of other things.
But this is a real technical challenge with this approach, is that once you have the machine up, which is great, that was a big like lurch forward, but having the CPU booted is not. You need like all of the programs that you want to be able to run, and the SPI-NOR it's a 32 meg payload, right, Josh?
Yeah, and it's going to have some rando AMD PSP crap in there as well. So it's not really like you can use the 32 meg. And also there are some constraints on the layout, I think. So I think we could get at most maybe 26 or 28 meg in there Right now, I think we're using about 9 because we're compressing it all. So it's
But this is like a challenge, and this is like also architecturally capped. So it's not like we can't put more SPI NOR down. It is capped at, I think it is capped at 32 megs total.
Yeah, you'd have to come up with some other magical storage device that you could access really early, without a bunch of setup, basically.
It's not architecturally capped to 32 megs. That's a supply chain issue. That's because that's just the size of the parts that we could source. We could put larger parts on it, but at the time when we designed the boards, 16 megs looked like, there's 2 16 meg chips. And so that's why that limitation exists.
Oh, okay. I thought that was AMD architectural. That's not AMD. So they can have an arbitrarily large SPI device. It's just that
kind of. The thing is that you can map that into the that appears in the physical address space of the machine. You can map that into the virtual address space. So if you wanted to stick more storage on there, you potentially could. But that, again, it just becomes a supply chain issue. And that's why we're limited to the size that we're limited to.
But the challenge is you have this like not very much storage space to actually have enough operating system to be able to go like do something sophisticated, like hit a disk over ZFS and actually pull in the rest of the system. So, Josh, kudos to you and Dan to you for the kind of collectively pulling this off, where we've been able to get enough in there to be able to pull in the rest. Because I think, Josh, you don't even execute to userland, right? I mean, you actually, this has been all in kernel.
That's correct. At the moment, it is all of the modules you would normally expect, like drivers and things, and bits of subsystems in the file system driver, and then the core like Unix kernel file, and then are all kind of jammed into the ROM, and then I wrote a small module whose job it is to, because like by the time we actually need to mount the root file system, it's actually extremely late in boot. Like we haven't made a process yet, but we have interrupts, we have like multiple CPUs, we have the full device tree stuff is like ready to go. Modules can attach as long as they're available in the ROM. So we pretty much just like attach everything that we can and go and look for the disk device, for instance, or the Ethernet NIC, if that's where we're trying to source a RAM disk image from at the time. And almost all of the code is just existing subsystem code that we're just calling into to do like the usual kind of Ethernet traffic stuff or disk reads and writes. So it's only like 1,000 lines maybe, or 1,500 lines. And it does also, we've got all this like hashing infrastructure in there already, so we can do like SHA-2 hashes and so on up the contents of the thing. So like there's a lot of subsystem that's already available in that 9 megs.
Anyway, and honestly, I don't know if you think the same way. Like the kernel is actually a pretty good development environment. I mean, it's like
our kernel is like, I don't know, you can sleep at pretty much any time. Like, I mean, there's a lot of stuff going on in there that I feel like has been crafted over several decades, and that is now a pretty good programming environment, honestly.
And you have something that's debuggable, and you've got instrumentable and so on. So it's actually, you can actually figure out what's going on.
Yeah, and then you've got a lot of flexibility once you get into the real kernel. I mean, when you first went, like the very first machine instruction, the x86 cores invoke, like that's a really constrained environment.
Yeah.
And then you have to sort of bend over backwards a little bit to get to the point where you can just load the kernel. One of the things that probably very few people outside of Oxide realize is that we enter the kernel in full 64-bit mode with virtual memory enabled, which is very unusual. Almost no system does that. Everybody sort of gets the machine up into, well, you either start in 16-bit real mode, or you get the machine up into 32-bit protected mode and you enter the kernel then. For us, we've like basically done the initialization of the boot core and gotten that thing fully turned on. And in many respects, we load the kernel image itself as just a standard ELF binary. There's kind of two places where we violate some of the assumptions that you would just normally make if you were just invoking like binls or something. And that's in the way that we treat the GDT, which I'm trying to fix now, and in some assumptions that the virtual memory subsystem makes about the layout of the address space after the kernel starts. But that's it. Otherwise, it's like You load this binary, you jump to its entry point, and then the kernel goes off and does its thing.
And so this is, and Dan, this is the piece that you written. This is Foible, the Pico host bootloader. And this thing is doing, it's just that absolute minimum that we need to do to get us to run a 64-bit executable, right?
That's correct. Yeah. I mean, that basically starts in 16-bit real mode. It does the whole little sort of amoeba evolving into a dog dance. Of,
so is.
You know.
I have phrased this as like you replay the history of compute starting in the mid 70s with the 4004 and the 8080. And
oh yeah, I mean you're wearing a disco shirt with a really big collar, and like the Bee Gees are playing in the background. It's right. A pretty constrained environment when you first begin, but yeah, you have to turn on protected mode and get into 32-bit mode, and then you have to load the page tables into the MMU and initialize that. And you have to turn on all the caches and make sure that memory protection actually works. x86 is a very strange architecture. There's a bit that you have to set in one of the architectural registers for page mode permissions to actually have meaning when you're in kernel mode. Otherwise, you can write to read-only memory and do all sorts of strange things. But yeah, and so Foible does all of that and then creates an environment which the kernel can basically sort of begin execution, assuming that it has been mapped and that it's fully resident in that, in the virtual address space and et cetera. And then the kernel. One of the kind of interesting parts of the contract between the bootloader and the kernel is the kernel takes over ownership of the page tables that the bootloader has set up. And so the kernel will like walk those and say, aha, okay, here are all my pages. And here's obviously the root and the internal nodes in the paging table radix tree. Let me take ownership of those. Everything else, including, oh, by the way, the bootloader that we just jumped out of, is fair game for recycling and becoming, just allocatable memory.
Yeah. Which is, I mean, it's interesting that in terms of like, because we totally control what that contract is between the bootloader and the operating system. I mean, it allows us to do things like that, where it's like, no, I've already set the page tables for you. Here they are. You don't need to actually go do any reinitialization.
That's right.
Yeah, that's really neat.
Critically, we build these things like together effectively. So like the Foible part is like the first 100 or 150 kilobytes of program text in the image. It's almost like a header. And then the 9 meg of compressed crap that the kernel is like, they're all one image in the end. Like they get built. There's no long-term stable interface between those components. We could change them all like tomorrow, and then we would rebuild both components at the same time. And like if we come up with a better way to do it, like
that's exactly right. Yeah,
like we don't have to deal with the foreverness of like well the BIOS and multi-boot and stuff work this way like forever now. Like
yeah. No, Foible actually includes it includes basically a CPIO archive that includes the kernel image as a blob that's compiled into the Foible executable. And that's just a Rust program, and it uses the include bytes macro to bring in the CPIO archive. And that just becomes part of the compiled ELF image that we generate. And then we have another program that'll turn that into something which is digestible by the PSP.
Steve, did you know this, by the way? I'm not sure that Steve knew this, that we are using include bytes to actually include the image from Foible.
I did not, but it makes total sense now that you say it.
I love include bytes and include-str so much. I cannot express how much I love them. I love them so much. I think include-str was almost my first moment with Rust, where I was like, Rust, I think I love you. Because I was super early on. I was like, I'm going to check this Rust thing out. Dan, you must have had that same feeling. I just feel it is so frigging valuable.
Well, it's funny. I did that because it was easy for testing. And then we started sitting down and thinking about it, because our initial, AMD has this thing called the embedded or embeddable file system, the EFS. And this is something which the BIOS sort of understands, right? And, the BIOS goes in there and it finds the sort of reset vector image, which is really what all of this code is, right? And the PSP will sort of load that. PSP, like, kind of responsible for doing some of the early initialization on the machine. It does the DRAM training. It finds the reset vector in the EFS, so basically in the flash part. It loads that into DRAM and then sets things up so the x86 cores will start executing in that code when they come out of reset. And I was like, okay, like I've written the bootloader, but now I need to test actually like booting the machine and loading the kernel. And so I was like, well, include bytes is a great way to do that. And then, we had this kind of intention that it's like, well, but we really need to read this image out of EFS properly. And then we sat down and we started talking about, we said, wait a minute. We treat Flash as this, not to overuse the word, but as this holistic thing. And so, the sort of parts of the AMD PSP GUI that we ship, the bootloader and the kernel image are all treated as a single unit with respect to what we ship on the individual machines. So there was no concept that we were going to update the kernel independently of the bootloader. And once we had that sort of epiphany, it was like, well, then why are we screwing around with trying to read this thing out of this thing? Just embed it in the kernel image and have this one tool that understands how to split things up cleverly so that they all wind up in RAM contiguously and stuff. And then let's just do it that way. And it ended up being a really nice simplification. And
I feel like I want an include bytes as my bootloader T-shirt or something, Dan. I feel like
as a small side note on include bytes, this finally actually feature landed in C23. Actually, it's still not in the C++ standard yet, but we'll see if they end up adding it now that it's in the C standard pretty quickly. But apparently, the first time it was discussed in the context of C standardization was September 1995. So it has been a long time coming for that, and as the blood, sweat, and tears of many people to get that landed. But apparently that's finally going to be in C23. So it's trivia.
There are 500 different coping mechanisms for this. I mean, we have one called elfwrap, which produces a .o file with a binary thing jammed in it with 2 symbols, one at the start and one at the end of where it's going to get mapped. And so we use that on to include firmware and drivers and stuff for wireless cards and things.
Well, I just feel like, and Adam, you and I have a long history of dorking with binaries after they've been generated, and it's just so nice to have something built into the language that allows you to be like, no, actually, I want all of this data from the file system sorted right now as part of the compile step. Just so nice.
Yeah, and it's beautiful as a macro too, because you can kind of surround it with the link section that you want it to land in, and
totally,
it's nicely integrated. It's very elegant.
It's great. So I want to get Adam. I know you got to get to dinner with the toddler. You got some other hands up that you want to get to maybe quickly. Simeon, do you want to go to you and then to Anno 770 there?
Yeah, thank you. This has been very interesting. I just want to understand Foible, the bootloader. Does it need to do things like speak to the SPI flash? Does it have drivers and that kind of thing? Was that handled by the PSP? And on either side of this endeavor, is how much help is it getting from whatever AMD is doing? And I guess the other question is it useful outside of context that you guys are doing? Could it be a bootloader that you could use on another system?
I mean, it could be. Bluntly, you wouldn't want it to be. It is really special purpose. We call it the Pico host bootloader because it is purposely designed to be small and to do the bare minimum thing. And outside of the context for which it was written, almost nobody is going to want that. So, I mean, you could use it to boot on another machine. You could certainly look at the code, which it occurs to me that repository right now is probably private, but there's
as I'm looking it up, I'm tempted to open it right now. It is private, but I'm just looking at it.
Go ahead. There's nothing in there that's proprietary or anything. I don't think it's all pretty pedestrian code in some sense. So somebody could look at that and be like, aha, here's an example of how you boot a machine from the reset vector up into 64-bit mode, which may or may not be useful for somebody. But if you were trying to run this on a commodity machine, I think people would be pretty sad pretty quick. I want to load this from a file from like a disk or a SSD. It's like, yeah, sorry, can't do that.
All right, we are going to see if I can deal with GitHub's verification code while in the Twitter Spaces.
I can do it if you want me to. I mean, I'm right here.
Okay, yeah, I've got.
That's not the correct procedure, so.
That's right.
Yeah, we just had a security training about this.
Just issues and PRs on Twitter Space. This is going to be great.
I mean, I'm not going to get fired if I click this button, right, Brian? Right, Brian?
I was Sorry, of course not. No, why? No, of course. But could you just do it for me? I'm coming into the office right now. But if you wouldn't mind, and also please send me some gift cards. No, actually, amusingly, GitHub has popped up its notification saying you have a notification code, and then I bring it up and it says no notification codes found. So yeah, go ahead, Dan. If I
all right, it says it's done.
There he goes, and my awesome. So yeah, so PHBL under Oxide Computer. You can now, the internet can now pour in. Can now be. In fact, I insist that everyone star this repo right now because that's how.
Smash that like button.
Smash that like button. Yeah, Dan's
okay. Like and subscribe. Send me those PRs, and if you find bugs, please let me know.
You don't have license headers on these source files in accordance with RFD.
Oh yeah.
Is that true?
Yes, it is true. I looked for trolling. I will send you a PR, Dan. Don't worry about it.
Nice. Okay. There we go. Right. We have our first PR. Very good.
I guess we need to take the people out of the loop.
This repo now under computer control. So, I mean, your question about drivers, I mean, you'll see it when you get in there. But like the part of the beauty about the way that Dan has done this is that it is pulled in as part of the image, so it's already been pulled in for you effectively.
Right, but that's the kernel that you're booting that needs to speak to disk and network and that kind of thing. What is by the time you're running this bootloader, something else has already spoken to the SPI flash, right?
The PSP has. But the PSP is an embedded ARM complex. Well, it's not. I mean, it's an application profile core, but that's an ARM complex that's resident inside of the chip, and that thing runs. That that's kind of in some sense the next frontier. For us, I think I'm okay saying that we would love to have access to programming documentation to be able to replace the proprietary firmware that's on there. That thing does boot a blob, but we haven't been able to sort of get any, usable documentation on it outside of AMD. But if we could, I mean, and I don't mean to speak for Brian, but I think Brian would agree.
Brian would agree. Brian would agree strongly. Yes.
Yeah, we would love to replace the proprietary firmware on there. We just don't have access to the documentation to do so.
So foible is the first instruction that the first instruction that is the first non-PSP instruction that's executed is foible.
That is correct.
Cool.
So, does that answer that question?
Yes, thank you. By the way, there's your AMD host builder image tool is also, I think, private.
That one we can't open source on this call. We will open source that very soon. That one is a little more complicated. And then Anno 770.
At the risk of nerd sniping, very busy people, I have two simple yes/no questions. With AMD getting their L3 slowly towards 1 GB, have you considered running a server without RAM, just using L3, which means you will have guaranteed L3 cache hits? Have you looked into that? Is the one question. And if you have looked into that, is that possible?
So we have not. And when you say run out of the L3, are you talking about running out of the L3 to boot, the way you kind of do historically for memory training, or are you talking about running out of the L3 in a more kind of persistent fashion?
Just run on the L3. There's no DDR anywhere in the system.
Right. So we actually and presumably we don't know how the PSP works because we don't see it. Certainly historically, one has to execute out of cache in order to be able to train memory. Memory arrives to us trained. So the memory training happens in the PSP. So we actually don't need to do that. So the good news is it's trained. The bad news is a minute has elapsed since the machine came on.
I also don't think we would necessarily want to do that. I mean, look, a gig is a lot for L3 cache. It's not a lot for sort of running, large scale server applications with large memory footprints. it's an intriguing idea. Like, what would happen if you just had a machine with no RAM in it? You just execute out of the cache. Sounds kind of cool, but I don't think that would be reasonable for a server class system.
It might actually depend on the workload. I can imagine that there are some people in finance which will pay a lot for the capability to not wait for DDR3.
Yeah, I mean, our machines have DDR4 right now, but I mean, yeah, that potentially makes some sense. There's a lot of variability in terms of performance if you have weird memory access patterns and things like that with DRAM. Still, though, like, would they be able to get away with only 1 gigabyte worth of total physical memory in the machine?
Yeah, it feels like the ratio of cores to memory is pretty far. I mean, there may be workloads for which that makes sense, but it is definitely. I mean, you're right, and there's a lot of L3, but I agree with you, Dan, that like it feels like you're going to need more than a gigabyte. Well, this has been it's been exciting. And Adam, hopefully you're not in too much trouble with hopefully the toddler hasn't been getting into the parental controls of the Wi-Fi router. Presumably that is what's been happening, but.
Yeah, he got in deep while I wasn't looking.
Exactly. But thank you very much, and this has been a lot of fun. Dave, thanks again for that. That tweet was great. You did such a great job summarizing why we feel anyway what we've done is so important, why we're excited about it. And great to have everyone here. Josh and Dan, very fun to have you both here. And Steve, Tom, thank you for your thoughts as always. All right. Thanks, everyone. See you next time.
Bye.
Bye.
Bye.